In this video, we will talk about the application of time value of money using annuity and perpetuity. As you know that we can calculate present value by discounting any future cash flow. Yeah. In the event of a series of future cash flows, we need to discount each of the future cash flow separately and then add them together to estimate present value of a series of future cash flow. However, sometimes number of future cash flows could be too many, which need a lot of time to discount each of all individual cash flows, as well as it creates possibilities of mistake in calculation. That is why in the event of a series of constant cash flows, the condition is constant cash flow, it is more effective to use formula to estimate present value. So let's start with the timeline. A simple timeline I will draw here. Here, say 1, 2, 3, 4, 5. So say same number 100, 100, 100, 100, 100, right? So, and this is time 0. So normally present value, when you discount any future cash flow, and future cash flow start from time 1 to any time in the future, right? If you look at this one, there are only 5 cash flows. We can discount each of these 5 cash flows and add them together to get the present value. Because this is only 5, we can do it. But when it was 50, it would be very difficult in terms of time and possibility of mistake. So as long as we know the number of cash flow and say, for example, here, the R is 10%, right? We can use a formula. Before we use the annuity formula, we need to know the criteria or condition that need to be fulfilled to be able to use annuity formula. The first criteria that all cash flows in the timeline must be constant, the same cash flow. Yeah. The second condition, the number of cash flows in the timeline must be definite. No number of cash flows. It could be 5, could be 50, could be 500, but number must be definite. And we are provided with a discount rate. In that case, we can put a simple formula. Let me write the formula here. Present value of annuity. So PV equal to C is the first cash flow. Cash flow 1. Because we normally take the first cash flow. The first future cash flow. So when we talked about present value mean time 0, we start cash flow from time 1. R over T, and T is the number of cash flow, right? So now if we insert the the value. So we can see here, C is 100, R is 10%, and T is 5, right? So if we calculate this, we'll get 379. Okay. So because this is annuity and we know the number of cash flow. So in this case, let's think differently. We know the 5 cash flow here, but it was told that this cash flow, this constant cash flow remain constant forever. So it means that the cash flow will continue forever. So it means that after 5, for example, it is indefinite. To apply the effect of indefinite, so when we write the present value of the annuity formula, let's do the same thing here. PV equal to C1 R power of T, and in here T was equal to 5. In here T is indefinite, right? When T is indefinite, this side, the value of this side is equal to 1. When cash flow is, number of cash flow is indefinite. So when it is 1, the present value is equal to C1 over R. And this is called present value of perpetuity. So in that case, if these are the cash flows, $100 forever, present value will be, which is 10%, and that is 1,000, right? So you can see the difference between annuity and perpetuity. Annuity is also constant cash flow, but you know the number of cash flow. And the effect of annuity is here. So this part, you can see, this part is 1,000. But the effect of annuity is here. This adjusts the effect of annuity. So this part was 0.379, and that's why it was 379. So if you understand the difference, you can use the same formula, but when you change the value of T to indefinite, this part become 1, the value of 1. So what is matter is this part. I hope it helped.